and 1. And just plug in the numbers. Negative 118.3.2 plus negative 914.2 plus positive 2.7. If positive, we want to acknowledge the positive side is 1. So eventually you get your delta G negative 2, 3, 4. 23.4. And negative. Right? So if it's negative, it's spontaneous or not spontaneous? Spontaneous. Okay. That is for this question. It's kind of a lot. You have to consider 3 equations, and it actually covers all the Hess law. Right? So any question here? Just remember, analyze your target equation. See what you want to get. See how can you get it from the given. And then do the modifications. Okay? So that is Hess law. Any clear? So the question you got in your test will be like very straightforward. But just don't forget, whatever you do for equation, you have to do the same thing for other logic. Yes.
So when you canceled out 302 and 202, you just canceled them out because of the yellow?
Because here is on the left, here is on the right. If the left and the right have the same element, they can be cancelled.
Not those. I'm talking about 302 and 202.
Oh, here? Because 3 plus 2 is 5, right? So here you should add together. But here you also have 5. So overall they cancel. So these 2 should be combined. So here you have 5. Okay? Good. Any other questions? All right. So that is another way you determine your delta G, right? Okay. So the last part for this chapter. This chapter, as I said, right? If you understand chapter 6, really nothing new. Okay, so far we kind of focused on the standard state delta G. So what if it's not under the standard state? Then you have to consider the quotient. Okay, if the reaction is not under standard state, okay, pressure not 1 or temperature not 25, so you have to calculate your delta G. It's related with delta G standard, but it's also related with the quotient. Okay, only if it has a equilibrium thing, right? So Q, if you forgot, Q is a quotient in chapter 15.7. You forgot what is Q, right? R is gas constant. And T is temperature in Kelvin. Okay, T is temperature in Kelvin. So this delta G 0 is delta G at standard. Right? So this delta G without a 0 is delta G at any state. I don't know, standard, maybe not. Okay? So Q, the key point is Q. Still remember, if you have this reaction, how to write your Q? Exactly the same as your K, right? But just this concentration don't have to be equilibrium. It can be concentration at any time, any state. If you use pressure, let's use gas. So it's pressure, say, pressure D. So that is Q, quotient. How to can you calculate quotient? It's related with coefficient number. Okay. So now, let's say an example. That's it. So if it's a non-standard, how to use your standard add this part. So that means whether it's delta G positive or negative depends on temperature, also depends on your quotient number. So let's say example. Okay, you're given, consider the following reaction at 298. Calculate delta G, here should be not a zero. Calculate delta G under this condition. And you're given delta G reaction negative 71. Because look at here, your pressure is not 1 atmosphere. That means it's not standard state, right? Because pressure not 1. Pressure must be 1 to keep the standard. Since the pressure is not 1 atmosphere, so it's not at standard state. So how to get your delta G? You know your delta G should be delta G 0 plus RT ln Q, right? You know that. So now let's say what are the given? You're given R is constant, temperature is given. If you can find your Q, so you can solve your delta G. So now, so this is a way how to get delta G. So how can I get my Q? You're given all the pressures, and you're given the equation. So can you find your Q? Apparently here should be QP, right? QP. Product, don't forget coefficient. Reactants, as I said before, chapter 15, 16, 17, 18, they are all related with equilibrium, right? So here comes again. Here should be pressure, and pressure, oxygen. Okay. So now just plug in the numbers. T nitrogen dioxide 2. Be careful when you calculate QP, you have to convert the unit to be atmosphere. If this one is given in atmosphere, if it's not given as atmosphere, you still need to convert it to the atmosphere. Okay? And oxygen. So you got your QP. Okay. Then you just plug it in here, but be careful. The unit for R is joule per mole per K, right? So here is kilojoule. You need to do a conversion. So delta G reaction equal to negative 71.2 equal to negative 0. Joule. I convert it to be joule. Okay, because the R here is joule per mole per K. Of course, if you want, you can convert this to be kilojoule divided by 1,000. So either way. Then delta G reaction equal to joule per mole per K. No unit, right? So you get okay, it's a negative, this large number. So be careful. If it's multiple choice, you look at all your choices is in kilojoule. So you just convert it to be kilojoule by divided by 1,000. Okay? So if it doesn't matter the unit, so it's you just leave it in joule is fine. Okay? Since it's negative, so the reaction is spontaneous or non-spontaneous. So the delta G at this non-standard state negative, so spontaneous. So all questions ask you about delta G can be converted to ask you whether it's spontaneous or not. So that is how to work with delta G at non-standard state. So now let's see. If here is this Q, right? If the reaction reach equilibrium, if you reach equilibrium, when you reach equilibrium, what happens to delta G? Still remember? The delta G should be 0. Means it can go forward and go backward. So it's an equilibrium state. So then the delta G is 0. When delta G is 0, means delta G reaction 0 plus RT. Your Q, portion Q, right? So Q equal to K. That is what we learned in chapter 15. So then your delta G standard equal to, this equation is also important. But this is only valid at equilibrium. Must be at equilibrium, okay? Only at equilibrium you have a K, because K is equilibrium constant, right? So then delta G standard equal to negative RT. So we're going to say this equation again in chapter 19, right? Since we are here, to summarize, so far how many ways we learned to calculate delta G standard. So this is one, and a very common one, right? You must have delta H. So I would suggest you write this in your notebook, because this is a summary about the methods to calculate your delta G at standard state. So this is what we learned today. You connect delta G with equilibrium constant. If you took higher level of chemistry class, This equation is used a lot. And you have to know what is R, what is T, what is K. Okay? So the R, if it's related with energy, is always 8.314. Right? So remember that. Then another equation we just learned, right? Sigma C. And P and reactant. So this is, let's put number 1, number 2, number 3. And number 4, what is number 4? We just discussed in the beginning of this class. Hess law. Okay? So all the math problems related with this chapter is here. And of course, plus the delta S stuff, right? So all the methods to calculate delta G is here. This we learned in the beginning, right? A very important one. This we learned last class. And this too we learned today. Okay? So they are all important. And you have to know, so this number 2 and number 3, number 4, they work for any conditions, for all questions. But the number 1, it only works if you have an equilibrium. You have to be careful for that. The other 3 methods works for any condition. Then how can I use which equation should I pick? Well, if you say you're given a table for delta GF, of course you should use this one, right? If you say, okay, you get multiple equations, that means you have to apply Hess law. If you say you're given equilibrium C, then it should be this one. If you are given delta H and entropy, then of course it should be that. Right? So that is the way you know which equation you should apply. All right? Okay, so any question so far? Equilibrium. Yeah? Sigma. Sigma. Means add everything together. Okay? And there are some problems you can work. For the ACS2. Also, when we come back from the holiday, we're going to start chapter 19. So make sure you go back to the pre-study for chapter 4 with the oxidation reduction reaction. Okay? So any question? Okay, if no more question, today we got a special thing for you guys. I got a special quiz. Special quiz. So it's so all the questions. So we may, you may need an extra 5 minutes after the class even. Okay, but maybe a little bit late. So I'll give you 15 minutes. I'm supposed to give you 15 minutes. So there are 5 questions. So I want you guys from a group. 2